At this very moment, a machine built by human hands is racing through the darkness of interstellar space at more than 142,600 kilometers per hour. It is so far away that if it suddenly fell silent today, we would not know for nearly an entire day. Its name is Voyager 1. As of July 15th, 2026, Voyager 1 is more than 25.5 billion kilometers away from Earth. A radio signal traveling at the speed of light takes nearly 23 hours to reach it. And on November 18th, 2026, it will achieve something no human-made object ever has before. It will become exactly one light day away from home. Think about that for a moment. Humanity has built a machine so distant that light itself needs 24 hours to make the journey. For nearly 50 years, Voyager 1 has traveled alone. It no longer belongs to the planets of our solar system. It has become humanity's first true interstellar messenger, drifting through the sparse, vibrating plasma between the stars. But now, as it approaches its 50th anniversary, this extraordinary explorer is entering the final chapter of its story. Its power is fading. Its instruments are being sacrificed one by one. And yet, against all odds, it continues the whisper back to Earth. This is the story of humanity's most distant monument. The story of Voyager did not begin with a launch. It began with a discovery. In 1965, a young researcher named Gary Flandreau realized that Jupiter, Saturn, Uranus, and Neptune would soon align in a way that happens only once every 176 years. This rare celestial arrangement would allow a spacecraft to steal a little momentum from each giant planet and slingshot itself toward the next. NASA called it the Grand Tour. To seize this once-in-a-lifetime opportunity, NASA built two identical explorers. Voyager 2 launched on August 20th, 1977, and Voyager 1 launched just 16 days later, on September 5th, 1977. Ironically, Voyager 1 launched second but traveled faster, eventually becoming humanity's most distant spacecraft. Originally, these missions were expected to survive for only 5 years, just long enough to visit Jupiter and Saturn. No one imagined they would continue their journey nearly 46 years later. These machines have outlived many of the people who designed them, and their greatest adventure was still ahead. When Voyager 1 arrived at Saturn in November 1980, NASA faced a difficult choice. Engineers could either continue exploring the outer planets or send Voyager 1 on a close encounter with Titan, Saturn's mysterious moon hidden beneath a dense nitrogen atmosphere. They chose Titan. It was a decision that changed Voyager 1's destiny forever. Titan's gravity bent the spacecraft's trajectory upward and out of the plane of the planets, ending any possibility of visiting Uranus and Neptune. Those worlds would instead become Voyager 2's destination. Voyager 1 sacrificed the rest of the solar system for a single moon. But that sacrifice gave humanity something even greater. It sent Voyager 1 on a lonely path leading beyond the sun's influence and into interstellar space. That single navigational decision is why Voyager 1 became the most distant object ever created by humanity, a title it has held since surpassing Pioneer 10 in February 1998. Sometimes the greatest discoveries begin with a sacrifice. On August 25, 2012, Voyager 1 crossed one of the greatest frontiers in human history. It crossed the heliopause, the invisible boundary where the solar wind from our sun finally gives way to the material drifting between the stars. Humanity had officially touched interstellar space. Despite popular imagination, interstellar space is not completely silent. It is astonishingly empty. Yet it hums with invisible vibrations. In 2021, researchers Stella Oker discovered a faint and persistent hum hidden within Voyager's measurements, the gentle vibrations of interstellar plasma surrounding the spacecraft. It was as if the galaxy itself had been quietly singing all along. Today, Voyager 1 continues listening to that cosmic music using its remaining instruments. Its magnetometer measures invisible magnetic fields, while its plasma wave subsystem listens to the vibrations of matter between the stars. Together, they are mapping a place no other machine has ever touched. Late in 2023, Voyager 1 nearly fell silent. Its flight data system, the computer responsible for packaging scientific information for transmission back to Earth, suffered a critical failure. For 5 long months, the spacecraft sent back nothing but meaningless streams of ones and zeros. Voyager was still alive, but it could no longer speak. Engineers at NASA's Jet Propulsion Laboratory began searching through decades-old documentation written in the 1970s. Many of the engineers who originally built Voyager are no longer here today. Now a new generation was attempting to save their creation nearly 50 years later. Eventually, they discovered the culprit, a single failed memory chip. Replacing hardware 25 billion kilometers away was impossible, so they performed something extraordinary. They rewrote the spacecraft's software and relocated portions of its code into surviving memory, testing every change across a 2-day round trip of radio silence. Imagine sending a command today and waiting 2 full days just to learn whether it worked. Finally, in April 2024, Voyager spoke once again. It was remote surgery performed across the vast darkness between the stars. Today, Voyager 1 faces an enemy that no engineer can defeat: arithmetic. The spacecraft is powered by 3 radioisotope thermoelectric generators that convert the heat from decaying plutonium into electricity. Every year, they produce approximately 4 watts less power than before. That loss may sound insignificant, but for Voyager, it means life or death. NASA has been forced to make heartbreaking choices. Instruments that have faithfully operated for nearly half a century are now being shut down one by one to keep the spacecraft alive. On April 17, 2026, engineers sent the command to power down the low-energy charged particles instrument after 49 years of service. And the sacrifices may not be over. The Voyager team plans increasingly ambitious power management operations designed to preserve heat within the spacecraft and maximize its remaining capabilities. If successful, these efforts could extend Voyager's mission well into the 2030s. Even now, nearly 50 years after launch, humanity refuses to let its greatest explorer fade quietly into the darkness. Long after its transmitters fall silent, Voyager 1 will continue its endless journey among the stars. It travels through interstellar space at approximately 17 kilometers every second, moving more than 1.5 million kilometers farther from Earth every single day. In about 40,000 years, it will pass within 1.6 light-years of the red star Gliese 445. Attached to its side is humanity's message in a bottle, the Golden Record, a 30-centimeter copper disc carrying the sounds of ocean waves, human heartbeats, music, and greetings spoken in 55 languages. Carl Sagan once described Voyager as a bottle cast into the cosmic ocean. Perhaps one day, somewhere among the stars, someone or something will discover that bottle and learn that on a tiny pale blue dot called Earth, there once lived a species that looked up at the night sky and wondered what lay beyond it. And perhaps that is Voyager's greatest achievement. Not the billions of kilometers it has traveled, not the planets it discovered, but the simple fact that it carries humanity's curiosity farther than anything else we have ever created. Even when our civilization has changed beyond recognition, Voyager 1 may still be traveling through the darkness, carrying the story of who we were. Because Voyager 1 is more than a spacecraft. It is humanity's most distant dream, still whispering back to the world that created it.